I'm going to talk about a change I did on assessment on a course. So the title is Extending a CPU Design Project to Reinforce Learning. And my name is Cruz from the University of Adelaide. So the motivation from this tip that is generic, just not just for people doing a CPU course, is that I was teaching a course that had some content that is linked to a MOOC materials. So in my case, it was computer organization course, and we were using the NaN to Tetris curriculum. So I have a good assignment for the course, but obviously because it's a MOOC, you can go online and click and find solutions for it. Okay, so you know what I'm going to do with this. So that's, you know, I'm going to talk about what we did. So this was the assignment. Okay, so it was the project 5 for the NaN to Tetris, that it was designing the CPU, that is called the hack CPU. And already the students have designed in previous projects the multiplexer and the registers, and so they have to put it all together. And I sort of feel it was a good project. I want them to learn, you know, to do it, but they can cheat. So what we did in the first iterations, okay, and that is not, and then I go with the next tip. It was, we actually make students write a logbook. So in our submission, there is like a logbook actually is like a chat or a blog that is attached to each student, and they just click and they have to type, you know, how they are doing things. So we did that for 2 or 3 semesters. And so the advantage is obviously that they, even if they go and find a solution online, they have to go and understand what the solution does, because they have to go and tell how they wrote it. Okay, so in a way, we are getting some learning done by them writing the logbook. The kind of downside is that you know, everyone end up with full marks. So, you know, it doesn't matter if you copy the code or you wrote it from scratch, and we want you to write it from scratch. Okay, so I was a bit unhappy because I sort of feel, you know, I want to use that assignment, but I want you to write it. So how I can encourage that? So here comes the tip. So so what I did is, on my second attempt, it was, I keep the log, but I extend the project. So I will show you next extension. So the idea is, I'm going to ask you to do 2 tasks. The first task has the solution online, and the second one doesn't. And then in my case, I split 50-50% marks, okay, but you can choose how much. And so the 2 aspects of it that are good is, first, that by repeating the task, you are going to learn more, okay, because you are practicing more. And obviously, what you want to do on the second part, on the extension, is something that builds on the previous part. So it's not double the work, you know, but you are reusing what you have learned on the first part on the second part, okay? And I make that extension unique. So I basically want to design a new CPU. I went online to make sure if someone has done anything, you know, can I find anyone? I do, and actually I found a really crappy one, so it's good. I'm not going to do that one. And I did have an idea what I wanted to do anyway. And now, you know, I have variations of it, so I can do a different extension another year, okay? And then also the one I saw, I think it makes it more interesting, but because by seeing 2 variations, you can, you know, you can learn more about the topic, okay? And they still have to write the logbook. So, okay, so this was my variation for the particular course. So what I did is I replaced, there was a register here, and I replaced it with a register bank of 4 registers. So I sort of felt it was more realistic, you know, a machine with registers. Because this was a 16-bit machine, I can only make it 4. I changed the multiplexer, so it has 1 more entry. Well, before it was 2, now it's a 4-way. And many of the logic overlaps is the same, because I don't show the slide here, it's on the paper. I have to embed my own decoding, so I make it overlap a lot with the original one. Okay, so that way, actually many students comment on the blogs when they started this. Oh, I actually can reuse this part. Oh, I can do this logic. I only have to change this bit. Okay. I thought overall it was, a very good work. As a teacher, I was very happy with the outcome because I felt, it was interesting. So what happened with the students? So actually, some students weren't very happy because they have to do more work, and some of them were really happy. But if I look at the marks they got for the assignment, so I did here a frequency one. So this is the most common case is they got full marks. I think it was 207, I can't remember the number. So more or less half of the class did both parts. About another 25%, well, so 50 basically is the people that probably cheated, copied the solution, wrote the blog, and then look at the second part, and on the logbook is like, oops, I don't know how to do it. I don't know how to start, okay? Then there was another group of people here, they got 65% that they did the register bank, so they managed to implement the 4 registers, but then they couldn't link it. So at least they got a bit ahead. Then there was, you can say, people that didn't attempt. I haven't checked, on previous semester what was the average that they didn't attempt, but I will think probably it's similar or a bit lower. And then there was a few people that obviously tried to do the first one and didn't get very far. But we can see that for most people it was an assignment they could do. I feel it was a very fair assignment because it provides a difference between the ones that find the solution online and the one that implement them. And the comments I got on the logbook, as I say, they is so really that the people that put the effort on the first part got a lot out of the second part. So in short, by providing an extension, I have achieved multiple benefits. I think the most important one is it reinforced learning, so they learn the topic more because they are doing it twice. Second advantage, obviously, it deters cheating because you cannot go and find the solution for the second part. And because of that, also it provides a more fair assessment for the class. Okay, so and as I mentioned before, because there is an overlap between both of them, is not double the work. So in short, the tip, I think it applies. It doesn't have to be CPUs. It applies to any course. So if you are, you're having a problem with solutions that are easy to find, how you can twist it to reduce cheating. But the more important thing is to improve learning. That's it.